Okay, in the last segment I said you had the formula C5H10, and I just came up with one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a double bond, which means it's unsaturated. Isomers means we're going to move that double bond around somewhere. Okay? If I move the double bond here, then that's the same thing as it being here, because your double bond is second, third from the end or second, third from the end. So that's the same thing. So you want to be able to ask, is this same, is it different, or is it an isomer? Okay? These are all different. These are all isomers because all of these have 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons, and that double bond's in a different place. Okay, so you were told to do some reviewing from your naming, and everybody knows that you need to do that. And that this pot is so big, we have to come up with a way of categorizing. So we're going to start with what we call an alkane. And this is a gift here. Alkanes have the formula CnH2n plus 2. Okay, alkane means we have carbon-carbon single bonds only. And therefore, for example, when we looked at this one, C10, 2 times 10 is 20, plus 2 more is 22. That's how we would come up with this. Okay, so this is actually a real gift. Okay, yay, this is a gift. If I have C15, how many H's will I need? 2 times 15 is 30, plus 2 more is 32. Poof. Okay? Now, to name this, you need to find the longest continuous carbon chain and name it according to the stem plus ANE. So the question is, what are the stems? Now, your book is not real great. Okay, this is page 238 in your book. Meth, 1 carbon. Eth, 2 carbons. Prop, 3 carbons. And then it doesn't really give you all the prefixes. So on the blackboard shell, okay, on the blackboard shell, you should see a PDF of what the prefixes are. Okay, so it should be pretty similar to this one. Okay, meth means 1 carbon. Eth, 2 carbons. Prop, 3 carbons. Bute, 4. Pent, 5. Hex, 6. Hept, 7. Oct, 8. None, 9. Dec, 10. So bute and maybe, well, these first 4 are probably new, but 5 through 10 are the same as what we did for simple binary molecular. So you're going to want to write these down and put them on some flashcards because you're going to need them in order to name. Okay? So I'm going to come back to my naming on page 2. 2 carbons, my prefix is eth, and my suffix is ane. 3 carbons is prop, and my suffix is ane. 4 carbons, all in a row, bute, ane. 5 in a row, pent, ane. 6, hex, ane. Okay? So we're going to come over. We're going to pick up 1, 2, 3, 4, 5, 6, 7 would be heptane. 1, 2, 3, 4, 5, 6, 7, 8. Octane. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonane. And finally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decane. And remember, all of these carbons have to have hydrogens to fill out their formula. C7, H, 2 times 7 is 14, plus 2 more is 16. C8, H18. C9, H20. We're following this formula, C10, H22. So you're going to want to practice this, okay? Because what happens is next we have to start putting branches on, and we have to take hydrogens away. Okay, so for example, I can give you decane, and then I could say, well, give me an isomer of decane. Well, okay, there's tons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one. My longest chain here is pentane, but then I have to figure out what am I going to do with my branches. Or I could do 4, 5, 6, 7, 8, 9, 10. Okay, so there's my 10. Here's my longest chain. 1, 2, 3, 4, 5, 6, 7, 8. So that is called an octane. But what am I going to do with those branches? Okay, so there are lots and lots of these. This is why on page 1, when I said, why is this such a big deal? It's because of these isomers. Okay, so carbon can rearrange itself, and it's a little bit of a learning curve. All right, so then we want to number the carbons such that the branches get the lowest combination of numbers in alphabetical order. Okay, so you have a variety of branches, but for simplicity, we're going to have a 1 carbon branch, methyl, ethyl. 2 carbon branch is ethyl. Okay? So, for example, on my drawings here, these don't have any branches. Okay? Page 3, this is now a branch. So we would call that a methyl branch, and it's 1, 2, 3rd from the end. We have to come back to that. We have to come back to that. Okay, down here, this is a methyl branch, methyl, 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 methyl. You have 5 of them. On this one, that's a methyl, that's a methyl. You've got 2 of them. Okay, so let's try a couple of these. Pentane and 2-methylbutane. Okay, so pentane will be 5, C5H12. 2-methylbutane, okay, so I'm kind of putting my structure over here. Bute means 4. 2-methyl means I'm going to put a methyl branch second from the end. And this formula is C5H12. So you can see they have the same molecular formula, but they have different names. So we're going to say that these are isomers. Okay? Octane. Octane is 8. C8H18. 3-ethylpentane. Well, pent means 5. 3-ethyl, 1, 2, 3, means I'm going to put a 2-carbon branch, 3rd from the end, and I'm going to count 1, 2, 3, 4, 5, 6, 7, C7H14. Excuse me, 14, 16, I can't count. Okay, so you can see they have different names and they have different formulas. So these are different. Okay, and then the last one I'll do for this segment, 1, 2, 3, 4 in the longest continuous carbon chain, that's butane. C4H, 2 times 4 is 8, plus 2 more is 10. 1, 2, 3, 4, butane, C4H10. These are the same. Okay? So what you want to do is you want to practice this, and then for the next segment I'll come up with a few more examples, and then we're going to have to continue on with our exploration of basic organic chemistry.